Hello, you're watching EASD TV. My name's Vivian Parry, and I want to introduce you to those who produced the best abstracts, and a wonderful set of people they are too. So, first of all, we have Jolien De Meulemeester.
Yes, Jolien De Meulemeester.
Thank you so much. We have Madeleine Hayman, who is from Belgium. We have Madeleine Hayman, who is from the UK via California, Glasgow, in fact. And we have Henrik Maagensen from
Denmark.
Yes, but say Maagensen.
In Danish or
yes,
in English?
In Danish.
Henrik Maagensen. But you won't say that. I'll just say Henrik Maagensen. Let's say that.
He's going to be very famous one day, so just make a note of that name. Okay. So, first of all, how did you feel when you discovered you'd won Best Abstract? Henrik?
I was excited. So I was very glad. And a bit surprised, I also think, because my field is a quite small field. So,
which is?
It's monogenic diabetes. So it's like...
So MODY and things like that.
Yeah, and MODY, yeah. Yes. Also, yeah.
Okay. How about you?
I didn't expect it at all. I was getting on the train and I read the email and I was like, oh, no, surely not. But I was over the moon at the end of the day because I do statistical genetics, which is not quite as common here. So it was really an honor.
Statistical genetics. It's a very wonderful field. And how about you, Jolien?
Yes, I was also really, really excited. I didn't expect it too. But yeah, it's really nice that you receive some recognition of your work. So that's really...
And what's your area?
I'm working on new technologies in type 1 diabetes.
Fab. Okay, so I'm going to get you to... So first of all, Henrik, why did you decide to go into this field, apart from the fact that I know your supervisor is Tina Vispel, which may have an influence on you?
I would say it's because Tina is my supervisor, because I've actually been in another field, studied something else with Tina, and then after medical school, I had to decide what should I do, and then Tina contacted me about the project with MODY, and then I thought, well, I know Tina, and it has been nice working with Tina, and then I went into the MODY field, and I think it's a very, very cool field because there's some individuals with MODY. There's not many of them, but there's not been studied that much. So it also has a big impact when we study something. It changes the research we do. It's clinical research with MODY.
It changes people's lives.
Yeah, exactly. And I have some of my participants in my studies that come afterwards, and they are always very thankful. And some of them have after we have made these studies, we have changed the treatment, and they have been very well regulated.
Okay, so very quickly, what did you do in this research?
In this study, we looked at SGLT2 and MODY3. So MODY is monogenic diabetes, so that's a form of diabetes that runs in families. So often if the father or the mother has it and half of the siblings, and they get diabetes at a young age.
And it doesn't respond well to insulin. Sulfonylurea is better treatment.
It responds well to... You can treat them with insulin, but that's a bit annoying. Yeah. You have to do injections. But MODY3, so there's some different genes, and MODY3 is the most common form. Have to treat it. Otherwise they will get complications. So the typical treatment or the first line treatment of MODY3 is SU. And that works well in low doses, but not at some point. Most patients need something else. And then in the last decades, we have got some new therapies for type 2 diabetes. And then we have one of these is SGLT2 inhibitors. So my PhD, we look at, can we use SGLT2 inhibitors in MODY3?
And what did you find?
I find that it works. In this study I'm present here, we looked at SGLT2 inhibitors work by excreting glucose in the urine. And the study I did, we compared how the SGLT2 inhibitors work in type 2 diabetes regarding the glucose excretion of urine and in individuals with MODY3. And we found they work exactly the same way or exactly similar as that in type 2 diabetes. And that was actually, some would say, okay, that would what we should expect. But the thing is, the gene that causes MODY3 is a transcription factor, so it regulates other genes. And it has also been proposed that it regulates the expression of SGLT2, so these individuals could have less SGLT2. So it's not, I think that has been known for a long time. So in that sense, it's a bit surprising that it works as well as in type 2 diabetes.
So what does it mean for clinicians or people living with MODY3? Very briefly, Henrik.
It means that we can have an individual with MODY3 that is treated with the issue, and then we have to intensify the treatment. And instead of using insulin maybe three times a day, they could take one pill in the morning, and they don't have to worry about hypoglycemia, and they don't have to worry about complications such as kidney disease or heart disease.
Fantastic. So no wonder they're worshipping at your shrine. So let me move on to Madeleine. Madeleine, why did you do the research that you did?
That's a great question. Well, I have to say that my field is regarding mental illness and cardiometabolic disease. And this is just a field that's really under-researched, especially when they are common occurrences together. And so what my study did was look at a common target for metabolic treatments for type 2 diabetes and obesity, GLP-1R. And we tried to see if there was any genetic evidence to see if there's associations with mental illness or negative mental effects if we keep targeting this continuously and with more popularity. And so my study really, it filled a gap that we aren't going to be able to fill with clinical data for a really long time. So it's really just kind of an interim study that gets us one step closer to figuring out what might be the case when it comes to mental health and physical health.
And what did you find in your study?
Well, we actually found that there were mental health associations within this gene region, but none of them were acting directly through the gene GLP-1R, which suggests that if mental health effects are happening, it's not happening directly through that gene, which just allows us a little bit more comfort in how we kind of go about targeting it, but it also allows us to look other places for these associations.
Fantastic. Okay. Jolien, why did you do what you're doing?
For me, it was also personal reasons. I have a little brother with type 1 diabetes, so I really wanted to make a difference for people with type 1 diabetes, to do something for people with type 1 diabetes. So I started looking for research, clinical research with patients that I see a difference in them. So therefore, I came into the University Hospitals of Leuven with Professor Gillard, who is really specialized in new technologies in type 1 diabetes. And I really like to see what new technologies, what's the impact of new technologies, not only on glycemic control, but also on person-reported outcomes, how they feel with the new system. Are they happy with their new system? Because that's also very important, of course.
So what did you do?
So I performed a study in adults and children with type 1 diabetes on a new technology, on an advanced hybrid closed-loop system, so the tandem control IQ. And we did the study in 19 centers in Belgium, and we looked at the impact on glycemic control and person-reported outcomes in this population.
And what did you find?
We found significant improvements on all glycemic parameters, and we found that people were very satisfied with the new system. They also experienced less impact of diabetes on their daily life. They experienced less fear for hypoglycemia. We also found that there were less work absenteeism days reported by the adults, but also school absenteeism days reported by the children and their parents, which is also a very important outcome, of course, yes.
Fantastic. So be very proud, all three of you, because to have best abstract amongst a very, very competitive field, having seen some of the rest of the abstracts, you've done fantastically well. Put it in big letters on your CV.
Yes.
And if you're watching, just make sure, as I said, make a note of their names. They are very fine scientists. Thank you so much for watching this. Thank you to all of you, and we'll be back with you shortly.